Welcome to day 3 of week 7 of CSI 41. So, I've been playing some Valheim recently. Just had some boating adventures or misadventures, as it may be, last night. I like the band choices for the quiz today. Yeah, Irish music. Irish music. Is the next CE on linked list? Yes, the next competency exam will be on linked lists. However, in order to do the third competency exam on classes, you must make an appointment at the TC. Muya may do a group TC study session or something like that. Nick, you want to chime in on that?
Yeah, all I need is, I think we have to both coordinate with the TC to schedule it because it goes through them. But I can basically go over probably the competency exam, question by question, maybe answer some questions about classes in general if you have any, and
Yeah, maybe I'll go over the, because there's a lot of people. The this one had the lowest pass rate of any competency exam so far, and to be fair, it's because it was harder than the ones in the past. So that might have taken some of you guys by surprise. I'll actually go over the competency exam right now, the take 2 one. But Nick, if you want to just kind of, like in a 1 hour session, just kind of go over classes and proper class design.
yeah, I can go over pods and the not pods. What's the opposite called? I can't remember.
ADTs.
ADT.
Yeah. Well, yeah. So an ADT is when you have a abstract data type. So like you have a queue, but you don't know how the queue is implemented, right? It could be done by using a linked list with some options turned off. It could be done using a different data structure entirely. It could be done using like a circular array. There's a lot of different ways of doing it. And the point is you don't know the implementation details when it's an ADT. That's the key difference. It's abstract. It has an interface, and you don't know what's happening behind the scenes, behind the curtains. You know, you don't actually know. Maybe it's a deck behind the scenes. It doesn't matter. So not pods works as well. Having a teacher of the games is awesome. I mean, maybe I'm just pretending to game so that you guys all think I'm a cool professor, and I actually just race my Ferrari down Friant or something. It's all a hello fellow kids thing. So yeah, the classes take 2 had the lowest pass rate I think of any one that I've done so far, and yeah, look at that. So if you failed it, don't feel bad, right? Only 5 people out of the 23 passed it, so don't feel bad about failing it. It was definitely the hardest one. So how do you do, fellow kids? That's one. Can you please have the Ferrari? Unfortunately, that was a lie. So 100% of people got that one. Well, that's good. What's the difference between struct and class? Struct's default to public, class is private. All right, nice. 100%, 26. So the hard one must be the other 3. Yeah. So here we go. Suppose you have a class named foo and you pass it a function like this. You are passing a foo by const reference, and so only 35% of people got this one correct. Okay, and so let's just kind of go over this again, because this is a check all that apply, which is inherently harder than pick one, right? So if you're passing a foo by const reference, the only methods you can call on f are constant methods. Okay, so when you make a class, you're supposed to tag any get method, right, as const, like const after the name. The reason being, that's the only kind of method you can call on a constant foo, right? When you have a constant object, you can only call constant methods on it, and only 42% of the people taking that knew that. So there you go. Then, but there's a lot of reasons why you might not be compiling, right? So maybe you just didn't make a function named print. Maybe the name of the function is called Bob. I don't know. That 85% of you guys got that one. It's absolutely true. If you didn't give it a method called print, it won't compile, right? So 35% of people said you can't call a function named print inside of print foo. That's not the case. Even inside of print foo, you can call print foo and it'll just recursively call itself. There's absolutely no reason why f couldn't have a function called print foo also or print, or there's no name conflict there whatsoever. And then finally, print is not a public method. Yeah, so if print was declared in the private section, or the protected section, which is also private, you guys haven't learned about protected yet. It's private, but with differences for inheritance, which we have not learned yet. If it's not, that's why I said not public rather than private. If it is not public, then you can't call it here, right? Because we are not within the foo class. And so 62% of you guys got that one. So, yeah. And so there's a lot of reasons why things won't compile. This is actually a job interview question that I like to ask. You know, here's some code. It's not compiling. Give me some reasons why it might not be compiling. And that's an open-ended question, you know. And there's a lot of reasons why things might not be compiling, right? You know, maybe I don't know, like maybe print is supposed to take a parameter and you're not giving it a parameter, right? It's an open-ended question. I just want to see how many ways a person can come up with, right? So, yeah. So that's the kind of question I like asking on a job interview rather than like C++ trivia. C++ trivia would be like, you know, I don't know, what happens if you compare an unsigned to a signed integer? You know, does the unsigned become signed or does the signed become unsigned? Right? That's C++ trivia. It does actually matter. And that's why you should not compare signed and unsigned, because the way that it works is backwards. It's backwards from the way you think it would work. You can't even connect to the call. You're not. You can't view this thing. Am I at the streaming limit or something maybe? Class, edit channel, bitrate 128K, user limit infinite. It's working fine. Well, you can always watch the stream later, I guess. I don't know. All right. Does it say it's full? No, there's only 34 viewers. So. Nah. Try turning it off and turning it back on again. Okay, so for my linked list class, I wrote this. And so this is what's called a copy constructor. And so you can see that a lot of people didn't, because here's the thing. If you don't write a copy constructor yourself, it doesn't sink in. And this is why I have you guys write linked lists and things like that in this class, because you need to write it. You need to do it in order for it to sink in. And so this is a copy constructor. It's a function named list with a const list by reference as the parameter. That's a copy constructor. So if you're going to copy one list to another list, this is the function it's called. But rather than writing a function, and if I were to write the function, I'd do what's called a deep copy. And maybe I'll show that in just a second, because the concept of a deep versus shallow copy is actually really important. But rather than going to that rigmarole, I just deleted it. Because C++ will generate a copy constructor for you, and it usually is fine. But if you're working with pointers, it's not fine. So if you're working with pointers, you typically need rule of three, right? You need a destructor, a copy constructor, and an assignment operator, in addition to the constructor. So rather than writing it, I just deleted it. And that's a perfectly acceptable way. And so that means if you ever try copying one of my lists, it won't copy. It'll throw a compiler error. And I do this because I don't want somebody to pass a list by value to a function. If you try passing a variable by value, it copies it, and it calls the copy constructor. And so by doing this, I prevent an accidental order in operation when it should be order 1. When you pass a list by reference, it's an order 1 operation. It just takes the pointer to it and passes it. When you do call by value, it duplicates all the elements in the list. So if you've got a billion elements, it will go through a billion times and duplicate a billion things, and then it prints out the first thing, and then it throws it away, and it deletes a billion things. And so by doing this, I prevent myself from accidentally doing order in copies when I don't need to. Okay. If you pass something by reference, it does not call the copy constructor. when you pass a variable by reference, what it does is C++ takes a pointer to it, passes the pointer in, and then dereferences it. So it's the original variable. It does not stop the destructor from running. This is not a destructor. And it does not stop you by passing it by const reference. If you pass something by reference, it just passes a pointer to it. It does not call the copy constructor. The copy constructor duplicates the list. And that will only happen if you do call by value. Call by value means duplicate the variable. And for most data structures, you don't want to ever pass them call by value. And I typically do this. I actually typically delete the copy constructor just so I don't duplicate it by accident. And then if I need to duplicate it, I create like a clone function that will spit out a duplicate if I need to. Okay. And then write a class using proper class design. And so 9 out of the 20 were able to do this. And so some people went way overboard on this and some people went underboard on it. You should be able to spit out a class using proper class design in your sleep by now, right? And the only part that there's kind of marginal is some people didn't have a distance function on it. So method means a member function. You have to have a member function called distance that returns how far it is away from 0, 0. So that's the Pythagorean theorem. And some people did everything but distance, and so I marked them as 0 on that. So there's probably a few people that should have passed that didn't, but that's in the direction. So I required a little bit more than just the boilerplate get set constructor member variable rigmarole. Okay. So the next one will be available whenever we get the study session set up with Muya, and then he will give you a password, and you will enter the password onto Canvas, and that will unlock the third one for you. Can you explain the proper get distance? Yes. So Vim, what are we calling this? Point or something? Point.cc. So class point. So down in main, we're going to say point p 34 cout p dot distance. So that's going to print how far away this point is. 34 is away from the origin 0, 0, which is 5, right? Pythagorean theorem. And so in our private section here, we are going to have, I don't know, doubles. I think it was x and y. And then in the public section, some people put distance in the private section, which doesn't help. So constructor point, I'll just do this, double new x defaults to 0, double new y defaults to 0. That way I don't have to make 2 different constructors or 3 different constructors. And then I'm just going to initialize x to new x and y to new y. If you wanted, you could do it like this instead. X equals new x, y equals new y. That is fine as well. I allowed both. This version here, though, is preferable. This way of doing it's the better way as far as C++ is concerned, because it allows you to initialize constant variables. And so if this was a const, I could do it like this, but I could not do it this will not compile. So if you want to initialize a constant, you have to do it like that. Are you going to upload the study session onto YouTube? I don't know if that counts. The whole point is to get kind of more individualized attention. All right, so point. Okay, so we got our constructor. Now we need getters and setters. And unfortunately, in C++, this is just kind of a annoyance to write, which is why you'll see me just in class when I'm on a time limit, I'll just spit out a pods rather than go to this effort. And so we got here double get x const return x. In C sharp, you can actually just write get set, you know, get sex. Wow, that's amazing. Get set. And so you can actually just write something like that in C sharp, and it'll just make them for you, which is really nice. And C++, you just take the time and effort to do it. Void set x double new x. And so this one, set x is equal to new x. YYP, set y. Oh, it's a constant. Yeah. So we got getters and setters, and then the last thing we need to do is make a distance function. It's a double distance, a distance method, and this will return hypot xy. Okay. So that is the class, and so that took, I don't know, a couple minutes to do. My compiler is auto-generate for getters and setters, yeah. Yeah, sure, you can upload it, it's fine. Just don't put the password at the very end. Make them embed it somewhere within. It just at some point he just raises up a sign with the password on it. No audio, make him watch it. That's not accessible. Yeah, fair enough. Okay. Close recording the password at the end. That's fair. That's fair too. Okay. Yeah. So hypot is the Pythagorean theorem. If you don't know that, that's fine. I accepted this as well, which is the square root of x times x plus y times y. That works too. Okay. So you should be able. I mean, that's part of what I'm testing. Like, there's a 20-minute limit on this quiz, and if you spend all your time like Googling like answers on the first ones. And you're not fast enough and you're not competent enough at making class, which is fair. You know, it's still second semester computer science. Then you're going to run out of time, right? And so that's why it's a competency test. It's a competency test. And to be fair, the trivia questions were not easy. Like I said, those two questions 2 and 3 were not easy questions. So the third competency exam should be easier on the trivia front. I might make just writing the class 2 points or something. So if you can write code, then you should be able to do fine. Does Pow use a for loop? Oh, no. Why would you use a for loop? I mean, there is a for loop, but it's not what you think. Right, so Mui is asking, does Pow do something like this? Like for int I equals 1, I is less than exponent I plus plus. So let's see here, int x equals 2. So let's see here. So is that what you're asking me? Like 2 to the exponent power equals x. Yeah. Good. Is that what you're asking? Like, do they do that as a for loop? So exponentiation is repeated. It is repeated multiplication, but it is not this kind of for loop. So actually, this is a good question for you guys. What is if exp is n? In terms of n, what is the big O notation of this for loop here? How many operations is this going to do in proportional to exp, proportional to n. What is the running time of this algorithm? Just 1? So if exp is 1,000,000, how many times is it going to do a multiply? So we've got order 1 as an option. We've got order n as an option. Okay. So, anyone else? Ordered squared? So you think that if we had so Shahab, you think that if exp was 1,000, it would do 1,000,000 multiplies? Or are you just guessing? Guessing, yeah, don't guess. It looks like this should be order n. So this loop will run n times, right? This loop will run n times. And each time it runs, this is one operation. So n times it'll do one work. So it's an order n algorithm. But why I equals 1? Because it's exponentiation. Anything to the 1 power does nothing, right? Yep. So this is a order 1 operation. Technically, behind the scenes. Because the optimizer actually does the math. So the optimizer knows this is a constant, right? X is always 2 to begin with. Exponent's always 8. And so the optimizer can actually look at this and be like, oh, the answer is always going to be 256. And so it actually replaces this loop with set x equals to 256. It's still an order n algorithm. If you're looking at the code, the correct answer, by the way, if this is on like a test, this is an order n algorithm, right? But optimizers are very clever, and if they can hard code in the answer, they will. And so the optimizers are very clever, and they'll look at this and be like, the answer is always going to be 256. And so it's just going to put x isn't even going to exist. There's not even going to be a variable for x. Because the only time x is actually used in terms of reading it is here. And that's 256. It's just going to put 256 there. Now, to actually answer your question, like, what does Pow do? So what is the difference between that and Pow, right? So if we were to say x is equal to Pow of 2 to the exp, what does the optimizer do? The optimizer is a part of the compiler that makes your code run faster, is what it does. And so as long as it can prove mathematically speaking, can prove something, then it's like, I don't have to do all this work. You're doing all this work here? Mm-mm. The answer is always going to be 256, so I'm just going to put 256 there. And so the optimizer is the last part of the compiler phase prior to generating assembly code. And what it does is it will eliminate variables that don't exist or that aren't used. It'll eliminate loops where it can. It'll restructure loops to minimize the number of loads. Like here, like rather than loading the value of exp over and over again, because exp is a constant, it will hard code in 8 here. It will not have to constantly load from RAM over and over again because exp can't change. And so the optimizer is really cool. And it will slow down your compile time a little bit. It's not actually that significant. I've done some testing, and it's a little bit slower, but it's usually not too bad. But it will make your code much faster. Much faster. You want to have the optimizer turned on. And I'll show you that in a second. Alias G++. I have O1 turned on by default, which is the most basic level of optimization. Fast compile times. It doesn't slow down compile time very much, but it will do the most basic optimizations, like what we just saw there. And O3 is better. So G++ dash O3 point.cc, that will turn on the full optimizer, and we still get 256 because most of the time you won't even notice the optimizer's on. You'll just notice your code runs faster because it'll only do things when it can prove that it won't change the correctness of your code. So Mui's question was, what is the running time of this? What is the running time of Pow 2 to the exp? What do you guys think? Let's turn off the optimizer. That'll make it too easy on you guys. So we're gonna read exp from the keyboard, and so we cannot hard code in the answer anymore. We cannot hard code in the answer anymore. So how many operations is this going to be? Order 1, order login, or order n. Got no clue. In this case, it should be order 1. Because 2 is a very special number. And you can actually, every time you multiply a number by 2, in binary you shift it left 1 bit. So if you were going to go 2 times 2 times 2 times 2 times 2, that's shift, 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 shift. And so you just, if 2 to the 5th power, you just take 2 and you left shift it 5 times, or 4 times. And that's it. So if you have a 2 there, it's if it's in any way intelligent, it would be order 1. But let's make it not, what if it's 10? Yeah, you can't do that, right? You can't do that. So for 2, it's a special case. It should be order 1 if it's implemented properly here. Oops. So read, please enter a number to exponent. So now we can't do that, right? We can't trick it with a we don't have tricky options anymore. So 5 to the 3rd power is 125. Oops, not x. We want. Uh, 5 to the 3rd power is 125. 100 to the 321st power is integer overflow. Okay. So what is the running time of this? Buzikian is going with 1. Mincrelli is going with 1. I'm pretty sure it's not 1. I'm pretty sure the answer is going to be log n. And you might be like, what? How? I thought it was a for loop. Well, let's see how they actually... Let's see what the documentation says. It might not be in the documentation. Pow. Pow F, Pow L. Pow, Pow F, Pow, Powell, Powell, Pow, 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 Pow. What the fuck say? Notes. Doesn't say. Really? You don't have the run? You don't have the runtime for one? See documentation for POW. Does not have a running time. Really? Well, it should be order login if it's implemented at all correctly. You know far too little about Big O. Okay, well, the best way about thinking about Big O is, like, if you think of like an addition or a multiply or a minus as one operation, then, you know, as you enter more and more numbers, you're going to do more and more work, right? And so just I usually I mentally just think like a million. You know, and so like, if exp is a million, if x is a million, and we got this for loop here. Let's take out the standard library one. So let's go back to this. So if exp is a million, Yoxtheimer, then this for loop is going to run a million times, right? Let's ignore the optimizer, which I don't think would work in this case anyway. So this for loop is going to run a million times, and if exp is a billion, then the for loop will run a billion times. And so the amount of work that it does is proportional to n. It's linearly proportional. If it's 1,000, it does 1,000 operations. If it's a million, it does a million. If it's a billion, it does a billion. And so it doesn't even have to be like 1-to-1. You know what I mean? Like, you know, if I did this, this is still order n. Yoxtheimer, this is still an order n operation, right? The reason for that is because if n is a million, it does 2 million. Okay. We don't care about fiddly details like constants and things like that. We just care, is it a linear relationship? Is it a logarithmic relationship? Yeah. Does the compiler have a formula to calculate in one shots instead of doing for loop a million times? The optimizer is very, very smart, and like if you if you do like if you add up all the numbers from like 1 to a million, the optimizer will know what you're doing and replace it with an order 1 operation. But for these purposes, don't worry about it. You know, the question is, you know, is it a linear relationship? Is it a quadratic relationship? Like if you did this. So if you did this, this loop runs n times. Then each time that loop runs, each time that loop runs, it does n operations. Then each time that loop runs, it does 1 operation. So it does n times 1, n squared operations. Okay, because it'd be technically 2n, but we drop the 2. Yes, yeah, we don't care about constants like 2 times n. It's just n. That's why it's not like an order 5. Like we never write like it's an order, you know, 8 operation. No, we don't care about things like it's 8 times slower. No, it's just order 1. Order 1 means the running time does not change proportional to the input size. Okay. Does the optimizer have some kind of lookup table? It's got super crazy advanced stuff in it that I don't understand. It's probably got a lookup table. It can actually recognize patterns of for loops and things like that. And so there's a lot of really smart math people that have put their math powers into the compiler. Who made the optimizer? Smarter people than me. Smarter people than me. A lot of smart people. Okay. So this is an order n squared algorithm here. So if n is 1,000,000, this will do, it does 1,000,000 times 1,000,000 operations, right? So that's, that's the best way I have of figuring out what something is. And then sometimes people will get confused. They'll do things like this. So they'll look at this and they're like, oh, it's a doubly nested for loop. That's 100, that's n, that's 1. So it's 100 times n times 1, right? So what's the running time of this? What is 100 times n times 1? What's the big O of that? Order n times 100 times 1 is order n. This gets students all the bloody time. That line right there kills CSI 41 students. The reason for that is because it looks like a for loop, and it is. But does the running time change based on n? Right? If EXP is 1,000,000, if it's 1,000,000,000, if it's 1,000,000,000, doesn't matter. It does not change the running time. The running time is constant. Constant running time is constant running time, even if it's a big number. Okay. So this is an order 1 operation. 100 things every time is 100 things every time. It's constant running time. It's a high number, but it will never change based on how much input you have. So it's order 1, this is order n, and this is order 1 also. That's a regular order 1, right? That's 100 operations. Each time we do one of these 100 operations, we do n operations. Each time we do one of those, we do 1, so it's 1 times n times 1, so it's order n. Okay. Does the runtime increases less and less for log n? Yeah. So log n. So how to go back to Mulia's original question, how do we actually do Pow like for realsies? Well, what we do is we actually will do a for loop for, I don't even know where we're at right now. No, get rid of you. Okay. For int I equals 1, I is less than log of exp plus plus. And so what happens, Mulia, is, and so this is an order log n algorithm. So what happens is you'll compute the following. You'll compute x times x, that's x squared, right? And so if you wanted to compute x to the 4th power, what's faster? Doing x times x times x times x, or x squared times x squared? Which one requires less multiplications? X squared times x squared. You've already computed this once. It's 1 multiplied to compute that value, and then it's the second multiply to get x to the 4th. Okay? And then if you want to compute, so x to the 4th can be computed in 2 steps. And then you multiply x to the 4th times x to the 4th. So rather than doing 8, 5, 6, 7, 8, rather than doing 8 steps, you do x to the 4th times x to the 4th, right? Which is x to the 8th. And so for 3 steps, you can do x to the 8th. For 4 steps, you can compute x to the 16th. 5 steps, x to the 25th. So you actually do the logarithm of the exponent. And then if you have something left over, like if you want to compute like x to the 5th, x to the 5th is x to the 4th times x, right? And so you know what x is, you know what x squared is, you know what x to the 4th is. So you've got actually everything you need. So if you're in between x4 and x8, you can just, x to the 6th is x to the 4th times x squared. You already know what x fourth is, x to the 4th is, you already know what x squared is, so it's only one more step beyond it. So for any number between x to the 4th and x to the 8th, it's just one more addition on top of it. So it's log base 2. So for every doubling of the problem size, as exponent doubles, you have to do one more step. So to go from x to the 4th to x to the 8th, it's only one more multiply. To go from x to the 8th to x to the 16th, it's one more multiply, because you just take x to the 8th times x to the 8th. So, yeah, Yock's number, it is really cool. And it kind of blew my mind the first time I realized that. Like, you can actually do exponentiation, like, more quickly than just multiplying them, right? Because you just write down your answers. So, when people say, is it order log n, is it base 2 or any other base, doesn't matter. Doesn't matter. Oftentimes it's base 2, but again, it's just a constant. So you can convert bases by dividing by 2 different logarithms, and so it just works out to a constant multiplier on it, and so we don't care. So fiddly details like, is it base 10 or base 2? We don't write it down. All right, so let's talk about shallow copies and deep copies, and then we're going to move on to stacks. Or let's do stacks first. No, I want to go over shallow copies and deep copies. So let's go over linked list.cc, and so let's actually make a. It's gonna kill me. Let's make a copy constructor. Okay, so rather than doing this, y2y, shift p, we're going to actually write a copy constructor. So, what happens if we don't do this? What happens if we use the default one? Do you have any problems? Why do we need to write a copy constructor? By the way, the homework should be pretty easy. I deliberately kind of picked an easy homework for you guys. So, make sure you do it, though, because the next assignment's going to use bridges also. So really, this is going to teach you bridges. All right. So let's say we've got our linked list class. We've got a list class. We got like 3 elements in it. 1, 2, and 3. And these guys are all like hooked up properly. This guy's previous is set to null. This guy's next is set to null. And then list has got a size, which is 3. And his head is pointing to here. He's got a tail. It's pointing to here. Okay. If you don't make a copy constructor, just like a public defender, one will be provided for you. So let's say I do this, and I say list wedding list, and I add these 3 people to it, and print out. Now let's say I do this, list wedding list 2, and I pass in wedding list as the parameter to the constructor. This will duplicate the wedding list using the default, because you see I've gotten rid of the delete on it. So this is going to call the default copy constructor. And if I print that list as well, wedding list 2 dot print, let's even do reverse print. Why not? That should be fun. And then, yeah, and then we'll quit. All right. So no address sanitizer. Do a little optimizing. LL cool J. Ah, damn it. We gotta get rid of those diamonds. String. So if I run it, you'll see that it prints Lester Wolf 2, and then I duplicate it and print out the duplicate backwards. And look, it worked. Wolf 2, Wolf, Lester, and blah, core dumped. Core dumped. Why? Why did this happen? I just used the one the compiler gave me, man. The compiler gave me this copy constructor. I'm just using it, man. My program died. Yeah, it died right when the program quit, so who cares? Yeah. Okay, so what's going on here? So first of all, let's understand what is the default. What does the default do? The default copy constructor and the assignment operator works the same way. The default copy constructor just says this. So for every element in the new guy, set it equal to the one in the old guy from the old guy. So what did we have? We have a head, and we've got tail, and we got size. So the default copy constructor is going to say the wedding list 2, I'm not going to write the whole thing out. Wedding list 2's head is equal to wedding list 1 head, and wedding list 2 tail is equal to wedding list 1's tail, and wedding list 2 size is equal to wedding list 1's size. This is all the default copy constructor does. The default copy constructor will go through all of the elements in a list and copy them. That's it. So my head is equal to your head. My tail is equal to your tail. My size is equal to your size. That's it. It just generates that for you. And for value types, for regular, if you're making an imaginary number, you've got a real part and an imaginary part. It works fine. Works fine. For value types, you don't have to follow the rule of 3, the rule of 0. Rule of 0. Don't write any of those. Don't write a copy constructor. Don't write an assignment operator. Don't write a destructor. Don't write any of them. The defaults work fine. If you just have a value type, like your complex numbers or your imaginary number or your fraction, all of those things just hold values. They're called value types. They just hold values. And for those, the rule of 0 works, and that's why I had you guys do them earlier in the semester. So you don't have to worry about all this rigmarole, okay? All this nonsense you have to go through. Now, the problem with this, the default doesn't know where the copy ends. It just copies head, it just copies tail, and it copies size. And as you can see, when we run it, it works up to a point. Okay, so what happens here? So what's happening is that we got our list, and it's got these 3 things here. And then we're going to create a new one, W2. And W2's head is pointing at the exact same spot in memory. And W2's tail is pointing at the exact same spot in memory. And its size is set to 3. So if the first list adds somebody to it, then the second list will have somebody added to it as well. And if the second list deletes somebody off the front, the first list is going to have somebody delete off the front. It's not actually a copy at all. It's actually going to be, and it's probably going to break things, because if you deleted head, then head is now pointing off into unallocated memory. And so this is a disaster. This is a train wreck of epic proportions. And the reason why it's crashing is because when these things go out of scope, when wedding list 2 goes out of scope, the destructor gets called, and it unallocates 1, it unallocates 2, it unallocates 3. Then the destructor for wedding list 1 runs, and it tries unallocating 1, crash, double free. Then it tries unallocating node 2. It's already been unallocated, crash, double free. Then it tries unallocating 3, crash, double free. Okay, so this is not what you expect. When you copy a list, you expect them to be 2 different lists, that each one has their own copy of the wedding list, and you can modify them separately. You don't expect them to be sharing pointers. Oops, why did I type :Q to get out of OneNote? So this is a problem. All right, if we do this with address sanitizer turned on, then you can see address sanitizer does a much better job of explaining it. We got to use after free, and so it's going to tell us which line of code. It's in the destructor on this line. It's getting deallocated here. Okay. So what we need to do is we need to do what's called a deep copy. This is called a shallow copy. So when you get this situation here, where 2 people are sharing the same head and sharing the same tail, and if you delete one, it probably breaks the other one. This is something called a shallow copy. A shallow copy is okay for value types. So if you have if you have like your complex number, then it'll just say a dot, or let's see. So if you have complex, if you say complex A equals B, what it's going to do, it's going to say A's real part is equal to B's real part, and A's imaginary part is equal to B's imaginary part. Okay, and that's fine. So A is going to have a copy of B. That's fine. It works in all situations except when you got pointers. When you got pointers, now these two guys, it just copies a pointer. Remember, a pointer is just an integer. And so the integer held here, like let's say it's 5,000, is copied to here. And so both of these guys are going to read from the same memory address and write to the same memory address when they should have their own copies of the data. So if you do default copy, the copy gets updated through the entire code. I don't know what that means. Like, if you delete it, we come back in here. If I just delete the if I delete the copy constructor, then this code should not compile. There. And so the basic thing that I do is I just delete the copy constructors, and that if I have the rule 3, like a lot of times I'll just delete it for convenience and to keep me from copying it by accident. And if I do need to make a copy, I'll just make a clone function. But let's say I want to do this the proper way, like the way that the standard library does it. Well, okay. So let's see how to do a deep copy. So rather than a deleted copy constructor, I'm going to do a deep copy. So what I'm going to need to do is new, for every node in the first one, I need to new something in the second one. So for, was it node pointer temp? Yeah, okay. For node pointer temp equals L dot head, temp equals temp points to next. So we're going to iterate through the other guy, and then we're going to add each node in the other guy to us. So for every person, the other person, for every node in the other person, we're going to call push back, passing in temp points to data. Okay. And this is an order what operation. What is the big O runtime of this algorithm? For every node in the other list, add it to our list. For every node in the other list, add it to our list. So this loop here, Bazookian's going with 1 every time now. Sorry, Bazookian, your luck has run out. This is definitely order n. Now the question is, when you push back on a linked list, is that order 1? Is adding something to the end of a linked list order 1 or order n? Not best time, we always do worst case time. So what is the worst case time to add something to the end of a linked list? Depends on the linked list. Depends on the linked list. The way that we've done it here is order 1, right? Because we got a tail pointer, right? So to add something, push back, right? So in order to, do you see how there's no for loops in here? Here's push back. What we do is we just allocate a new node, we attach it to the bottom of tail, and we move the tail down. 3 operations, order 1. Okay. This is an order 1 operation. If, however, we wanted to save on memory and not have a tail pointer, then every time we did a push back, we'd have to start at the top, iterate all the way down to the bottom, and then push it to the bottom. And so you can make it bad if you want, but I don't recommend. Okay. So this is a order 1 operation, and then if we do this, everything works fine. Okay. So Lester, Wolf, Wolf 2, Wolf 2, Wolf, Lester. And then the destructors, because I have newed those memories, and you notice I didn't even do a new here. I'm just calling pushback because I already got code to do it, right? So it's going to duplicate all those nodes. Each one of those nodes gets duplicated. Where we had 3 nodes before, we got 6 nodes now. And when the destructors get called, list 2 purges all of its people. When the destructor on list 1 gets called, it purges all of its people. Everything's good. So this is called a deep copy. And it is order n. And that's why I delete it most of the time. So I don't like doing copies by accident. Okay. And then you do the same thing for the assignment operator. The assignment operator, you do the exact same code. If it was a singular order n, I don't know what that means. The pushback can only happen one time in this case. So if the other list has 1,000,000 elements in it, 1,000,000 times we will do a pushback. And each pushback is order 1. And so 1,000,000 times we do 1 operation. So it's 1,000,000. Will the optimizer change your linked list class to linked list using default push? No. No. Optimizers do not change your class. No. It won't rewrite it using the list class. Among other things, it's laid out in memory differently, and so if you had any pointers, they would all break if you switched classes on them. Okay, so that was that. Let's talk about the stack class. So we talked about queues last time. So a queue is a linked list where you can't push at the front or pop at the back. A stack is very similar to that, but in the opposite direction. So thank you, protected mode. You're protecting me from myself. All right. So stacks are the opposite of a queue, kind of. Let me hide the video so you can read that. There we go. So stacks are the kind of the opposite of a queue. So, but they're very similar to a queue. They're also implemented using usually another data structure. The standard library stack class isn't really a class. It's like the queue class. It's just another class with features turned off. So whereas queues are FIFO, the first person in line is the first person to come out of the line. Like think about lining up at a movie theater. If you remember when those things were open, the first person in line would get called forward by the teller at the ticket window. The last person to come in would be the last person to go up to the teller. LIFO stacks are the last person in is the first one out. So for example, if you think about your fridge, when you put things into your fridge, they typically go in the front of the fridge. And then when you get food out of your fridge, you typically get things out of the front of the fridge. And what happens is that means the food at the back rots, right? And so if you guys have ever seen the grocery store milk aisle, do you guys know how the milk coolers work at a grocery store? Have you guys ever seen this? Like how they load milk at a grocery store? Yeah, they're not normal fridges, and they're for exactly this reason. Because if you constantly put stock in the front of the fridge, people would take stock off the front of the fridge, and then the stock at the back would grow old and stale and rot. And so at a grocery store, you actually load the fridges from the back, and that makes the fridges at a grocery store FIFO. So the oldest one in the cooler is usually the one right in front of you, and so you take that out. So you're constantly taking the oldest milk, and that's why some people will like kind of peek over the tops of the milk and reach over and grab the milk in the back. You get fresher milk that way, I guess. And so if you just have a regular fridge, though, a lot of times you will see people rotate stock. And so if you're like at a if you work at any I don't know, place that like sells sodas and things like that, or like maybe not sodas because it doesn't matter that much, but like snacks and things like that, like beef jerky, you will see them occasionally rotate the stock. So what they do is they go in and they actually pull all the stuff out and they put the newest stuff at the back and the oldest stuff at the front because bread. And the reason for that is because a normal fridge is a stack. The last thing you put into the fridge is the first thing you take out of it. Okay? Or if you're talking about pancakes, if you're stacking up pancakes, and you put 1, 2, 3, 4, 5 pancakes on a plate. The fifth pancake, the one at the very top, is the first one to come off. So that's why it's called a stack. In fact, it's based on like a stack of dishes, or like a, you know, if you've ever been to like a buffet, you know, they've got like dishes, you know, and so the, you know, when you put the clean dishes on the stack, they kind of come up like this, and then this is called an increasing stack. And so if I were to put a new dish on here, it'd come on the top. But let's say somebody comes up and takes a dish off the buffet, to, you know, and they go to the buffet, the top one comes off, and so the oldest one is just going to kind of sit there for a while, going stale. A stack of trays, yeah, stack of dishes, stack of pancakes. That's where the term stack comes from. That's sort of the mental conception used for it, and that's why with queues we think of a queue as like, you know, a line of people, right? So there's a line of people, and so that's why mentally, you know, that's the front of the queue, that's the back of the queue. That's why with the queue function, it's called front and back. But with a stack, the functions are called top. Right? Not front, top, because it's just a different mental conception. It's really the same thing, but it's just visual, like we sort of visualize stacks as being vertical and queues as being horizontal, I guess. Okay, so you can actually use the vector class to make a stack. Because for a stack, all you need is push back and pop back, and that's what a vector has. Although on a stack, we call it push and pop, usually, and then top to get the top value. So yeah, and so basically the C++ stack class, here, then stack.cc. Here, let me make a super cool stack class stack. We haven't learned templates yet, have we? No, not yet. Okay, so we'll just hold strings again. So push pop. I'll do it the C++y way. Pop. And then string top. Return back dot. There we go. I could be a standard library author. So there you go. That's basically all that's all it is. So the stat class is a vector class with functions turned off. Right. You can push new elements onto it. You can pop elements off it. Pop, again, in their wisdom, doesn't return a value, whereas I think it probably should, but whatever. So push, pop, and then top is the top value of the stack. And then you can also have size, I guess. That's all you need. And so if I were to do this stack, what's a good example of a stack? It's basically reverse queue, yes. Top we'll call the last in. It's last in, first out. All right. So if I have a stack and I'm gonna what's a good metaphor to work with here? Ladder. Okay. So I'm gonna have a list of students that are climbing up a ladder. So ladder dot push student A student B, student C, student D. Then while ladder dot size string S is equal to ladder dot top. Yeah. S climbs back down off the ladder. And ladder dot pop. Okay, so let's say I've got a big 100-foot tall ladder. Student A starts climbing up it. Student B starts climbing up it. Student C starts climbing up it. Student D starts climbing up it. And then I'm going to say, all right, everyone come back down. Who's the first person to come back down off the ladder? How do you replace the string so fast? Like, okay, so YYP, copies and paste, right? And then R is replace. And so I type R, Shift D, and then D3D deletes 3 lines, YY 3P, paste it 3 times, R Shift B, R Shift C, R Shift D. Okay. So the last person to go up is D, so D will be the first one down. G++ stack.cc. Space down. And so you see D comes back down off the ladder first, then C, then B, then A. So that's a stack. That's it. Look at me. I'm a professional programmer. I just wrote a whole data structure. 10 seconds. Instead of pop back and pop push back, can you do push front and pop front? Vectors do not have a push front or pop front. So no. If, however, I wanted to use a deck, then yeah, sure. Okay. Vectors do not have a push front or a pop front for a reason. And the reason is they don't want people to make an order n operation by mistake. Push back and pop back are amortized order 1. Push front and pop front on a vector is order n. And so they did not add functions for them deliberately so that people would not do that and make order n mistakes when it should be order 1. Okay, any questions about this? If you really wanted to, you could use insert and erase and things like that and make order n versions of it, but it's just going to be, there's no reason to, it's just slower. If you wanted to use push front and pop front, then just switch the vector to a Q. Right, so. Or not a Q, sorry. Deck. But decks are slower than vectors, so I just use vector. That's stacks. That's it. Can't really make it any harder than that. Why is infix postfix format a thing with stack? So yeah, that's a use for a stack, and that's kind of what I was hoping you guys would ask me last time. It's like I introduced the Q class, and I was like, so you might ask me why you would use this class. Yeah. So what's the use for a Q? What's the use for a stack? So even though I would not use the stack class, I just use a vector. Even though I wouldn't use the Q class, I just use a linked list. Even though I wouldn't use them, conceptually, there's a good use for queues and there's a good use for stacks. Like these are taught in this class in data structures because these are like the fundamental building blocks of like a lot of things, right? So like stacks are used for like you know, if you want to check to see if parentheses match, right? So every time, you know, like let's say you're writing a compiler and somebody has like x is equal to 3 plus 4 divided by 7 times 9. Right? Anyone see what the problem is with this line of code? A lot of students, when they try to do parentheses checking, they just count how many, you know, open parentheses there are and how many closed parentheses there are, and if they match, then it must be valid, right? Need another parentheses? Nope. We got 2 open parentheses, we got 2 closed parentheses. What is wrong with this code? Parentheses are in the wrong order, yeah. And so what we'll do is we will, when we see a open parentheses, we push it onto the stack. And then we're like doing all this stuff. When we get to the close parentheses, then we're going to evaluate everything between there and the open parentheses. So we pop, 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 pop until we get to the open parentheses. And then we replace this whole thing with 7. And then we parse, 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 parse. Oh, pop. And you try popping. You're like, wait a second, the stack is empty. That's a compiler error. And then you quit. You throw an error, quit. So if you try popping off a stack that's empty, you're like, oh, no, 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 no. You got one too many open parentheses or closed parentheses or something, right? And so, and if you end with a semicolon, let's say you had this code here. Let's say you end with a semicolon, then the stack is not empty at the end of it. And so you're like, oh, no, 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 no. No, no, no. You were supposed to not have any parentheses left on the stack, right? So ideally, when you finish, it will have an equal number of parentheses. Right? And every time you open, and then you get a close, you pop, and so that's how you check for balanced parentheses. You use a stack. And you evaluate everything in between the parentheses as an algebraic expression. So that's a classic example of use of a stack. For a queue, because nobody asked this last time, for a queue, why do you use a queue? Well, it's very common for like a network buffering or any kind of buffering, right? So it's very common to have producers and consumers. So a producer is something like a hard drive. It's producing data. The hard drive's spinning. It takes a while to like get up to speed, and then the hard drive head has to seek around. And once it finds the place where your data is, it starts spitting it out to your program. And so maybe your program is busy at the time. It's not reading any data. So what's going to happen is all that data is going to go into a queue. And so what happens is you've got the hard drive producing data, and then you've got your program consuming data, and these things don't have to sync up with each other. The queue is used in between as a mediator, as a buffer between producers and consumers. And so you have an Ethernet card in your computer, and the Ethernet card or the Wi-Fi card, data will be coming in from the internet, and the operating system hasn't read it yet. And so the Ethernet card will have a buffer inside of it, and the buffer will start filling up with data. And then whenever the operating system gets around to reading the data, it pulls data out of that buffer. And that means your operating system doesn't have to be ready for the data. It can just come in on its own accord, and then when you're ready to read it, you read it. And the size of the buffer limits how much you can do that, right? If you've got a tiny, tiny buffer, then your Ethernet card will fill it up very quickly, and unless the operating system's on top of the ball reading it out, the Ethernet card will return, hey, I'm full, stop sending me data, and it will throttle your internet speeds. And so having a nice buffer size, a nice queue, in the hardware, actually, it's the Ethernet card itself has a queue inside of it, and data comes in, A, B, C, D, E, and then data comes out in the same order, A, B, C, D, E. And that's a classic example of a queue. Anytime you have producers and consumers working asynchronously with each other, then a queue is usually sitting proud and center in the middle. Okay? So, yeah, but I still wouldn't use the queue class. I wouldn't use this class either. I would use a vector if I needed it. Because, like, what if something crashes and I want to print out all the elements in my stack? I can't. This interface here has no ability to print the elements in it, right? So I would probably use a vector, because the vectors really are just stacks. Like, they're really equivalent, right? Push, push back, pop, pop back, top, back, size, size. Like, the only difference is that we visualize the stack as being like a stack of pancakes or a stack of trays. So it's top instead of back. It's top. That's the only difference. Just how we visualize the stack. That's the only difference. Code-wise, you just use a vector for a stack. Okay. So that is it for today, guys. Your homework assignment should be fairly easy. Make sure you do it. Because your next homework assignment will be using bridges, and so this assignment is, you're using linked lists. It's kind of really trivial use of linked lists. It's really much easier than the last one, but it should get you guys up to speed on bridges. And so for your next homework assignment, you're going to be making a linked list in bridges and visualizing it. So maybe pay attention to how the code is. Pay attention to the example code, how they're building a linked list. See if you understand it, because you're going to need to do that yourself for the next one. Would you recommend using insertion sort to sort the list to find the median? You can. I don't think the lists aren't that big, so you can probably sort it any way you want. Even though insertion sort's kind of meh, you can sort it using insertion sort if you want. Okay. We're not doing anything too big, so it should be fine. That's the only hard part, I guess, sorting it. All right, team, that is it for today. We got IS50B coming in, my programmers. Wait, are you a programmer? It's programmers. And so they've been doing some coding and game development, and who knows what we'll do today. I think we'll be talking about map design, stuff like that. So thanks, you guys. Applause emoji right back at you. All right. And hopefully from doing the Zybooks on stacks and queues, you guys kind of got it. It's really easy, I think. I don't know. Linked lists, I told you guys would be hard, but stacks and queues, I don't know. If you don't understand it, then just send me a message. Okay. Thanks, guys.